Hey everyone, welcome back to Simple Learning AI. In the last video, we explored what deep learning is. Today we're diving into something super exciting, the types of deep learning models. If you've heard terms like CNN, RNN, or GANs and wondered what they actually mean, this video is for you. Let's break them down one by one, in the simplest way possible. Let's begin. Feed-forward neural network, FNN, is a type of artificial neural network in which information flows in a single direction, from the input layer through hidden layers to the output layer, without loops or feedback. It is mainly used for pattern recognition tasks like image and speech classification. Convolutional Neural Network, CNN, are made for images and visual data. Instead of looking at the whole image at once, CNNs scan small parts, called filters or kernels. These filters help identify patterns like edges, textures, and shapes. They preserve spatial structure, which makes them great for photos. Here's the layers in CNN. Convolutional layer. The first and most important layer in a CNN is the convolutional layer. Here, small filters, or kernels, like 3x3 or 5x5 slide over the input image and perform element-wise multiplication. The goal of this layer is to extract low-level features such as edges, corners, and simple textures. These filters learn weights during training that help the network identify important patterns in the image. With more filters and layers, the network can learn more complex and high-level features like shapes and objects. Activation layer. Right after convolution, we apply an activation function, commonly ReLU, rectified linear unit. This layer adds nonlinearity to the model, which allows the network to learn more complex functions and relationships in the data. Pooling layer. After convolution and activation, we usually add a pooling layer. The pooling layer reduces the spatial size of the feature maps, which lowers computational cost and helps avoid overfitting. There are two main types of pooling. Max pooling picks the maximum value in a region, preserving the most dominant features. Average pooling calculates the average value in a region, smoothing the features. Pooling also makes the model more robust to small translations or rotations in the input image. Normalization layer, optional. Sometimes we add layers like batch normalization. This helps stabilize and speed up training by normalizing the inputs to each layer. Fully connected layer. Finally, the outputs from the convolutional and pooling layers are flattened into a vector and fed into fully connected, FC, layers. These layers work like a traditional neural network and learn nonlinear combinations of the extracted features to perform the final classification. The output is usually passed through a softmax function to convert it into probabilities for each class. Recurrent Neural Network RNN information is fed back into the system after each step. RNNs allow the network to remember past information by feeding the output from one step into next step. This helps the network understand the context of what has already happened and make better predictions based on that. For example, when predicting the next word in a sentence, the RNN uses the previous words to help decide what word is most likely to come next. Long short-term memory LSTMs are a special kind of RNN that fix the memory problem. They have gates: input gate, forget gate, and output gate. These gates help them remember what's important and forget what's not. Perfect for long sequences like long sentences or conversations. Example use case: chatbots, translation apps, generating music. Generative Adversarial Networks, GANs, are like a game between two AI models. Generator tries to create fake data, like fake photos. Discriminator tries to spot which is fake and which is real. They compete, and over time, the generator gets so good that its outputs look real. Example use case: creating fake celebrity photos, AI-generated art, enhancing blurry images. Autoencoders are used to compress and reconstruct data. First, they learn to shrink data, encoding. Then, they try to rebuild the original data, decoding. If they succeed, it means they understood the most important parts. Example use case: image compression, removing noise from photos, detecting fraud or anomalies. Let's quickly recap the types of deep learning. FNN, basic structure, no memory. CNN, great for images and visuals. RNN, for sequences like text or time series. LSTM, RNN with memory for long sequences. GANs, for generating new, realistic data. Autoencoders, for data compression and anomaly detection. Each has its own job and strength, and together, they power a lot of the smart tech we use every day. Which one do you find the most fascinating? Let me know in the comments. And if you learned something new, don't forget to like, share, and subscribe to Simple Learning AI. Thanks for watching, and see you in the next video.